surveillance, protection, and prevention. And increasingly, we need to look at our negation capabilities, at least have our structures, have our technologies in place, and as and when a nation looks at enhancing its space control from defensive to offensive measures, these technological demonstrations or technological capabilities are there for the nation to take a decision in time and space. And therefore, while space application dilemmas are there, essentially you have only two options: maintain status quo and do not deploy space-based systems to orbit based on our present policy of space enhancement and defensive measures, or go ahead, develop technologies, retain a space enhancement capability presently, but retain the technological edge and the know-how to translate into offensive space control capabilities as and when a threat manifests or a deterrence becomes essential for a nation for its self-defense. To conclude, I'd like to say that space is central to a network-centric warfare and digitized battlefield, one. Two, India must integrate space capabilities at all levels of operational command, expanding senior leaders' understanding of utility of these forces relative to other tools. That's a responsibility that we in each service, our individual space cell, are carrying out, and empowering our leaders with this sort of a capability. And the third, that the threat from our adversary in this domain is real. We cannot ignore it. We as a nation have to decide and be empowered to look not only for the present, but also for the future. Thank you very much.
Thank you, General Shivani. It was really a very good expose on the space aspects, and I'm sure the audience would have gathered from you, would have benefited from your knowledge. We now have Admiral Air Marshal Dev Ganesh, who is an expert in his own field and who's working with the Honeywell Corporation. He's going to talk to us on sensors, a very integral part of any battlefield. So over to the Air Marshal.
Thank you, General. Good afternoon, ladies and gentlemen. Before I start, actually, if you do notice my face going through contortions, please rest assured I'm not making faces at you. I'm going through a two-take, which might take me by surprise once in a while. I want to change our level. So far, throughout the day, we've been talking at a very conceptual and a very wide-ranging level. And I want to bring you down to the nuts and bolts level. We are talking about enablers, which allow our space sensors to be part, an integrated part of a digital battlefield. Now, it sounds very nice, and you can speak about it and you can cloak it in very wide-ranging phrases and words. But the fact remains is this: ultimately, we have to get down to the nuts and bolts of the issue. We have to know what components we need to do exactly what and to what purpose, and how that fits into the big picture that we have of a digitized, integrated battlefield. So what I'm going to do is just describe about 3 or 4 sensors and the part that they play, because everything, frankly, that there is to be said on a digitized battlefield has been exposed by various speakers. Now, the first thing we need to do is look at the battle space, or look at a digitized battlefield, and see exactly what are the various components that we're looking at. Okay, we're looking at surveillance, which has already been covered by a variety of sensors, could be panchromatic, IR, SAR, multi, or hyperspectral, or imaging. We could be looking at electronic intelligence and analysis of voice and data, not very far away, as I'll cover later. Communications, that means allowing us to communicate with people on the ground, in the air, or at sea, across very wide distances. And we want to control our transmission. For example, if I got a satellite at 36,000 kilometers altitude in a geosynchronous Earth orbit, it's going to have a huge footprint on the ground. Maybe I don't want certain areas outside my own country to get that. Now, how do I do it? It is possible to form the beam emanating from that satellite in such a way that it sticks to only areas which you want that signal to go to. And this assumes even more significance when you realize that in order to jam a satellite, and it is possible to jam a transmission from a satellite, it is necessary to be within the footprint of that satellite. If you're not within the footprint, you can't jam it. Now, all the above, what you see, depend to a very, very large extent on very accurate positioning, by which I mean the satellite should be aware of where it is in three-dimensional space. And pointing, that means if it points to a place on the ground, it should point at only that place with a high degree of accuracy. Now, obviously, both these things are, have a lot to do with each other. If you point at a place, you might be pointing accurately, but if your own position is inaccurately estimated, then the basic area that you're pointing at will show up as a huge error on the ground. It will show up as an error which is as huge as the inaccuracy happens to be. I'll give you a live example. Many years ago, we were testing a laser-guided bomb on a Mirage. The laser-guided bomb had a CEP, a circular error probability of 1.3 meters. 1.3 meters is pretty good. When we used that laser-guided bomb in one of our dummy exercises, we got an error of more than 900 meters. 900. We tried to figure out everything. We checked the computer, checked the weapon, checked the sighting, checked everything. It was all okay. Then we checked the coordinates that had been fed into the nav system. Now, most of these weapon aiming systems use the GPS coordinates or the WGS 84. That's a World Geodetic System 84 system of coordinates. All of our ordnance issue maps and most of the maps we're using uses the Everest projection, right? And the error widens as you go away from the center of the sheet. So that's how errors take place. Somebody is told to make a map, he drew two lines, made a map, measured it out, and fed the coordinates into the computer. Now, computer will work perfectly, accurately, even better than 1.3 meter CEP. Only thing, it gave the wrong coordinates. Now, somebody else spoke about how we need to coordinate and integrate all our resources. It's not good enough just inventing or buying a new weapon system. You've got to make sure that everything fits into the philosophy behind utilizing the weapon system. And this is a classic example. You spend millions of dollars buying a weapon system, but you put in the wrong coordinates, and that's what you get. So it starts from a very low level and extends all the way to the top to the satellite, and then comes back to the user on the battlefield. Now, there might be a huge difference in the data that is sent up and data that is sent down. Not that anybody was careless about it, but certain things had been overlooked. That is where accuracy in various things, and I'm pointing of only two things, that is positioning and pointing, assumes great amount of accuracy, great amount of significance, sorry. Air and land vehicle management, we have a number of systems. We have a number of systems aimed at managing the amount of aircraft that you have. About 10 years ago, or maybe more, the Air Force lost AN-12 aircraft over the Himalayas somewhere. AN-12, which is phased out now, was a large four-engine troop carrier. It took about 7 or 8 months before even the wreckage was found. And I'll be covering a system where you get a feedback on a screen or the position of that aircraft every 10 to 15 seconds. So that's how much we progressed. Now that is how the battlefield is being digitized. A battlefield doesn't mean you're shooting at somebody or he's shooting at you. You could be in a battle against the elements. You could be in a battle against time. You could be part of a system that is using that warfighting capability of the armed forces. So everything has got to be able to merge and work together. Okay, now this is the first gadget I'm going to talk about. It's called a miniature inertial measurement unit, or a MIMU as short. You know what an accelerometer is? An inertial measurement unit uses a number of accelerometers that compare their data and tell the satellite where it is. That's all that it does. If you move it from place A to place B, it will tell the satellite, okay, I've been moved from here to here, and my new position is so and so. It sounds very simple, but this is where 99.9% of all your error starts. Now, this is what receives the data when you request coordinates on the ground. If you're under fire and you request your satellite to be pointed in a different direction, you want some more intel or intelligence from the other side, this is the gadget which you will be passing your information to. Now, ignore the rest of the figures are actually technical parameters which you may be interested in, but this is the basic function of that gadget. Normally, each satellite has about 2 of them. One of them is used at any one time. The other is just a backup. And these are a very high quality in the sense most of them are typically meant to run for about 15 years at a time. So it's not 24/7, it's 24 into 365 into 15 without a break, right? So that is the kind of assurance that you get. 99% of all the requests you will make from the digital battlefield will come into a box like this. A slightly more advanced version is something called, is based on a fiber optic gyro, that is a FOG. I stands for interferometric. This is not aimed at being a technical discourse, but I just want to make you understand as to the criticality of the components to which you're making your requests. This is the actual hardware that's going to go on the satellite. Now, what does interferometric mean? Interferometric. If you see a star in the night sky, it's just a point of light. Suppose you could magnify it somehow, and so that it has a finite shape. Now you draw a line from the left edge and the right edge and measure the angle in between. This instrument is capable of measuring that angle and giving you the answer in radians or milliradians, and there are 57.4 radians in a degree. So you can see the accuracy of that kind of measurement. Okay, now this is where you want an IMU that's slightly more accurate. And ultimately, who is all this information going to benefit? It's going to benefit that warfighter on the ground. This is the thing that gives him the information that he needs. So it's a very important piece of equipment. I spoke a little while ago about positioning. Three-dimensional space it's a very different thing. Actually, I have a slight difference from the general when he's mentioning that maneuvering in three-dimensional space is more or less the same or very different from the air, from the ground, from the water. It's different from the air, but it's very similar. Both are three-dimensional. On that count itself. The main thing is that you need to know, or the satellite needs to know exactly where it is. Now try and imagine the big picture beyond the Earth. The Earth is moving around the sun at about 18 miles per second, right? A satellite is moving around the Earth at less than 7 miles per second, otherwise it will hit escape velocity. So that forms a solar system. The solar system is moving around the galaxy as 250 miles per second, right? And our galaxy is going at about thousands of kilometers a second, moving all over the place. Now that movement has got to be fed, corrected for, and applied to a gyroscope. All these are errors which affect a gyroscope. Depends how close you are to the nearest gravitational body, so that will determine the amount of error that creeps in. But the error is there. It might be to 5 decimal places, but the error is there every time. So we have a thing called star mu, that is the star IMU, which looks at the starscape is able to recognize constellations, takes a fix from 3 or 4 star positions, and computes its own position over the Earth to a very, very high degree of accuracy. So this is even more accurate than the earlier one. So it would be, if I were to hazard something, it'll be within about 3 decimal places of a meter. Of a centimeter. That kind of accuracy is what we are talking about. On the right, you can see a spherical thing. That's a IFOG, that's a fiber optic gyro, and the bottom of that is the scale. That scale is showing, in case you can't read it from that side, is showing about 2.5 inches. That means we've made it miniaturized to put a fiber optic gyro about 2.5 inches in diameter. Those are the kind of gadgets that you're talking about when you talk about digitization of the battlefield. And when you know that, when you figure out, when you imagine that these gadgets are designed and guaranteed to run for 15 years without a break, then one can understand why the price is so high in this. So overall, in the positioning, we've got all these components. I won't read them out. The main thing is, what I haven't spoken about is radiation hardening. Now, as you go around, you get a lot of radiation from the sun, which creates a lot of damage to the satellites. We won't speak about that much now. The lost in space feature. Lost in space means that if you have a sudden a microsecond of power failure on the satellite, and it's okay in a microsecond, but you don't want the data to be lost. You want the satellite to recover itself and take off where it was last known. So it is the capability of the satellite to scan once again the entire starscape and to figure out where it is in that, reorientate itself and land in the same position. Basically, that's what is meant by the lost in space feature. Okay, now it's not just limited to the Earth itself. We've got this kind of technology has been used for various other interplanetary and not intergalactic, though one mission has left the galaxy, but basically interplanetary probes. This is just for information. There is something which is very critical. All satellites have got a minimum of 3 of them, called a reaction wheel. Now, all of you know how gyroscopes work. So when you want to turn a satellite, let's say you have a camera and you want to move it from place A and focus on place B, what do? You got to turn the satellite. So you use a reaction wheel, which has got a rotor, which has its forces of precession. So you alter the speed of the rotor, that alters the precessive force, and that turns the satellite. Once again, 15 years, 24/7, every day. We've got a pretty good reputation in this that we're very proud of. We've had no failures yet. The last thing I spoke about was a beamforming network. Now, basically, I've given you the gist of the whole thing. We're pretty good at making networks that conform to the user's requirement. So even within India, if you want to focus on some parts of the network, you don't want a part here, you don't want a part here, it can be done, it can be arranged. This is done by major producers all over the world. Now, when we get down to aviation, there's more to aviation than just getting up and landing. Like I said, we need to be aware of our resources. Where are they at all times? It's okay if you've got 1 aircraft, but suppose you've got 100 aircraft going all over at different heights. You've got civil air traffic, and you all have read and you know enough about the congestion that is there in the air. So you need something to track your airborne resources at all times. And this is not to be done by you. You need an automatic tracking system. So that anytime you look at something, you will be able to get its position. If you look at the bottom picture, you can see a ops room kind of a scenario with a couple of screens on it. Now, on that screen here, what is shown is a picture of larger picture, but on that screen will be a blip for every aircraft fitted with this gadget, a blip that comes up every 10 to 15 seconds, anywhere in the world, right? The only thing, obviously, is that the aircraft should be in the visibility of a satellite. Now, this is a very, very, very good, a tool which many, many countries are using, both in peace times, whether it's an oil rig using it, or for disaster management, or for anything else. Now, along with this, you have various other voice and data services. That means in your aircraft flying over, let's say, the UK, you can talk to a person sitting in that ops room out there. You can send them a message. We have a thing called HUMS, which is basically it's a maintenance system which automatically scans the various systems in an aircraft and gives an alarm to the ground in case anything is out of ordinary, which the user can define. If your hydraulic pressure is supposed to be 100 kilos, 100 psi, and suppose it goes up to 110, it will report that. Okay, now that kind of system can be integrated into this, and it can sound a warning to your ground base, and your technician can have your part ready on the tarmac even before you land out there. So it envisages all situations, including military situations, if you suddenly come under hostile fire and so on and so forth. Okay, the communication aspects of this, like I've just covered, I won't go into great detail here, but it has everything, including transmitting data, including voice, including any kind of textual data, or maybe even pictures. Okay, what we use is a constellation. You must have heard about the Meridien and the Inmarsat, the two main constellations of satellites all over the world, about 60 odd satellites. Basically, they convey messages all over the world when you want them. Inmarsat is setting up, so we're told, Earth station, a ground station in India. They've already been allotted land by the government of India. If that happens, I believe the Air Force is keen, the first to jump on with the next product, which I'm going to show you. Because for security reasons, obviously, everyone wants their data coming into their own country. They don't want it to go somewhere else and then be sent to us. So this is something called Osprey wings, which is much like the one I just described, but this is a very small version. It's about so big, 8 or 10 inches, and you can clip it onto the windscreen of your helicopter or your car, actually. And if your aircraft goes in for servicing, it'll take you 10 minutes to take it out from here and put it on the next aircraft. It's got more or less the same features, and it's got a SMS capability. Now, this is already in use, actually. On the right, you can see various paramilitary forces and local police forces in India using it, like Chhattisgarh, Andhra Pradesh, Maharashtra, so on and so forth, including in Orissa, the CRPF and the BSF, including in the Naxal, infested areas. So this is something which is cheap. I mean, the size of this is, this little gadget, when you fix it, is less than about, I think it's less than 2 lakhs each, after conversion at today's prices. But the main thing is it requires very little maintenance, and it operates off the Inmarsat network. So these are the kind of things that when we talk about digitization of the battle space, what exactly are we talking about? We're talking about data getting from headquarters to the guy in the field, to the foot soldier, or vice versa. Now, how's it going to happen? By a few crucial components like this. Right now, this has got to be molded into your procurement cycles, into your doctrines, into your philosophy, exactly what you want to know. The first system I spoke to, the SkyConnect system, I know the Air Force is very keen on it, but the Air Force got something which they made themselves, which is very much better, which should be coming up soon. Right? But the last one I showed you, that small little gadget, the best thing about it is it doesn't have to be on an aircraft, it can be on a land vehicle. So that might make it interesting for the Army, because if you have land vehicles all over, you can keep track of each one of them. And the first person to use it was, does anyone know? First person to use it was Chandrababu Naidu, who fixed it on his state transport buses or his lorries, so he could keep track of them, where they were in the state, and is he pulling a fast one when he's saying my truck's gone bad, or has he just gone home for the weekend? Basically, that's what he was using it for. But it's cheap and it's affordable and it's effective, which is the main thing. So in this, I've just tried to give you a close-up view of the kind of hardware that's involved towards digitization of the battlefield, of the battle space rather, and what are the benefits that we can draw from all this. I look forward to your questions during the Q&A session. Thank you.
Air Marshal Ganesh gave us a very good insight, a little different from what was given to us by the previous speaker. And he also introduced real-time equipment that is available from Honeywell. This shows that how important space is getting for the military warfighter and how much emphasis is coming onto the space. But at the end of it, we must remember that finally all these efforts, whether in cyber or kinetic weapons or sensors, space, anything, finally it is beating the enemy in time and space. Finally it comes to that only. And all efforts will be made to disrupt his decision cycle. Currently, it may be through these efforts which we've spoken about today. Maybe in a year or two, something new will come up, but the principles of war, which were enunciated many, many years ago, remain the same. It's been really wonderful sitting here with my co-panelists and hearing them. We are now open to questions.
So one macro level question to AVM Ganesh. On behalf of Honeywell, long established cooperation, how do you respond to the concern on the part of user that your softwares, your hardwares are only coming from the destinations outside India? They are not within the country, and therefore there are certain concerns, serious concerns on the part of user. Even General Kocher had, I think, referred to in his thought process. So can you respond to this? How do you answer? How do you counter this concern?
Yeah, perfectly valid apprehension actually, because the last thing you want to experience when you've invested so much in a system is that diplomatic or political relations or something changing and the switch gets turned off or the tap gets turned off. Quite right. To my mind, as I think Colonel Lars also said some time back, and there is no denying the fact, and I totally believe in this, by the way, even though I do work for Honeywell, but indigenization is the key. Having said that, we can't afford to be left behind in anything. We can't afford to wait 30 years for a LCA or things like that. You know, we don't want that thing to happen. So what we are doing right now, and what I think ISRO is also looking at right now, is going into transfer technology agreements, maybe short term. For example, you know the last device I spoke about, a round thing called a reaction wheel assembly? They're being made in Trivandrum, okay, by ISRO, by a branch of ISRO called the IISU, that's the Inertial System Unit. But they are stuck for one or two components. Otherwise, they are not able to attain the level of performance required for this. So next week on the 5th is their Mars mission going, as you must have read in the papers. That doesn't have ISRO designed reaction wheels. It's got made by another vendor. Whichever vendor is not really important. Okay, but it's not made by an Indian vendor. To get it made by an Indian vendor, you need to get over your technical difficulties in order to be able to manufacture it yourself. Now, it is a process which has no shortcuts. You have to learn how to design. You will make mistakes. There will be losses. Fine, right? Even, I mean, whether the US or any other manufacturer has gone through periods of this learning curve. What I would suggest in direct response to your question, sir, is that basically the safest thing to go through is a transfer of technology and not just a, lip service or a naam ke vaste transfer of technology where the actual stuff is made somewhere else. You must learn how to acquire the technology so that if the TOT agreement is for 10 years or 20 years, fine, go through that. At least after 30 years, you should be able to make it yourself. If that is the case, then I think it's worth it. And rather than just carry on buying and don't have a clue how to make it, I don't think that is the way of going about it. We need to acquire the capability of making ourselves. It is. I know for a fact it is because I've been trying to push this idea for the last 1 year, and it is. We've had a number of talks with ISRO, and it's not that they are not doing it. They are. At the moment, there's a lot of components on the aircraft, on the satellite, which are coming from all over the place. Now, what we are offering is you want to learn how to make it yourselves, fine. But at least you have to acquire the knowledge. You can't just say, I want to make it myself and do nothing about it. In that case, nothing is going to happen. I hope that answers your.
The question is for General Shivani. It's got three small parts. Are we doing anything for sat communications mobile? That is mobile SATCOM, the one. Second, is there an agency within the defense forces which is looking at the orbital intelligence in view of the Chinese capability of space? And the third and the final subpart is this navigational system that you talked about, the first satellite having gone up. I'm not talking about Gagan, because that's an announcement. I'm talking with the RNS. Does that have a beacon facility also? Does that have a beacon facility? Okay.
Thank you very much for your question, sir. Firstly, as regards the SATCOM capability and whether we have an agency looking at the requirements of SATCOM, yes. Let me just explain to you that we have an Indian Army Space Cell which looks after the entire requirements and foresees the future for the space utilization by the Indian Army, and similarly other services too have. And we have got an integrated space cell at the IDS levels, which synergizes all the three service requirements. And we have a DSA, Defense Signals Establishment, which is there, which is the technical interface, because the outcomes of space are generally general staff oriented. So as far as technology is concerned, to dovetail with the general staff's requirement, you have the DSA, which dovetails itself along with the Indian Army Space Cell and with the other agencies to look at the specific bandwidth requirements for a SATCOM, look at our mobile SATCOM requirements specifically for the borders in the north and in the east. And we have a roadmap, and it's well in place. And our procurements accordingly are also progressing. We do visualize certain challenges in terms of our bandwidth requirements for the future, which are to come up, but they are being adequately addressed at the national levels and assurance given that they would be met when so required. Second is the issue of orbital. Again, we are looking at in all these aspects of our capabilities. As regards RNS capabilities, I need to get back to you on this beetle capabilities, but certainly it's a very important capability that we look at RNS, because we've had at times where we've had blackouts which we have faced in the field formations, and we do not have 100% assurance levels or the ownerships as far as the present systems which are external to the nation. And the challenge today that we are facing is in the design of the user-oriented receivers, which should be capable of receiving multiple inputs from the various systems, so that not only there is redundancy in the system, but there is a foolproof arrangement.
General Kocher, this question is to you. You made a very good definition of what should cover the whole cyberspace. Now, of late in this country, most of the concerns around cybersecurity has been going around the content part, which is absolutely nonsense and doesn't have any relevance other than some India bashing that happens, or bashing our cyber laws. But coming to the national cybersecurity policy which came in, or which was announced in July, and then to operationalize it, to have an institutional position of a coordinator, not the current scenario where the deputy NSA coordinates everything. Where do you see the defense structure coming in that situation, where the whole ecosystem, going from the basic block of having a secured chip right up to patch management, or having a security operations center looking at it? Where do you think we are going? Because if I look at the banking or the power sector or any other things, I don't see really much of a comprehensive activity happening. Thank you.
Let me first thank you for at least agreeing with what I've said. Why do you think that defense needs are different from the needs of the civil? Except for the timelines, otherwise the needs are the same. Whether it is cyber defense or cyber offense, corporates are also engaging in the same type of cyber offense. Timelines, the targets, possibly that is where the difference comes in. And that is where any technology of cyber is a dual technology. It can be used in defense as well as in civil. It's only the application which differs. So saying that there should be different development for defense in the core area of cyber may, to my mind, not be quite correct. Yes, we have to make it defense usable by various other physical means, hardening it, various other things. But the core function remains the same. And when you're getting into net-centric environment, what you draw from the net, whether it's a bank or a defense establishment, it draws the same thing. It draws data from secure repositories and feeds it back. So data integrity is important, network availability is important. Giving different definitions for defense and civil may not be quite correct. I hope that answers your question.
Thank you, sir. In continuation of this, actually, India is planning on launching an ELINT satellite for the first time. ELINT standing for Electronic Intelligence, and this is going to be, the project is going to be led by DRDO, and of course with ISRO looking after the space aspects. At the moment, the scope of this is to check out everything, all kinds of transmissions, including cell phone conversations. Now, I'm not worried about breaking any security laws here, because everything's on the internet. It's already there. Just Google for network security in India, and you'll get it. But they are planning for a constellation, maybe 3, maybe 5 of these satellites, all in low Earth orbit. Thank you.
Last question, because I got an indication that we're already short of time. Yes, please. Yeah.
General Kocher, how long you will take to accept the cloud system for your technological system? Cloud technology.
Where? In which field? Defense communication cloud technology is already made an inroad. Only thing, it is not a public cloud, it's not a hybrid cloud. We started working on private clouds. You see, whenever a technology gets introduced, it pays dividends to the defense not to go in for the cutting edge technology immediately. Let the technology settle down. Maybe the number 2 technology, which is in vogue and which has proven its worth, is the one that defense will go in for. Okay, so to expect the defense to go into a public cloud may not be the right answer, but to reap the benefits of cloud technology, we have to go into private clouds. That the defense has already started. Okay, ladies and gentlemen, it's been a pleasure sitting here, and I thank you all on behalf of my co-panelists for being so patient with us. Thank you very much.
May I now request the chairperson, Lieutenant General S.P. Kocher, to present a memento from SP Publications and a set of clause publications to our esteemed panelists. Major General A.B. Shivani, and AVM Dev Ganesh. I now request Mr. Baranwal to kindly present a memento from SP Publications and a copy of clause publications to the chairperson, Lieutenant General S.P. Kocher.